Hello buddies, welcome back to my YouTube channel. In this video, we are going to see basics of machine learning with handwritten notes. In this, we will see what is machine learning, types of machine learning. In this, we will see supervised learning, unsupervised learning, what is semi-supervised learning, and reinforcement learning. After that, we will see difference between two major types of machine learning, that is supervised versus unsupervised. Then we will see what are the steps to develop a machine learning model. After that, we will see how we evaluate our model, the confusion matrix for classification like accuracy, precision, recall, etc. In simplest explanation ever, in easiest way possible, I have explained the confusion matrix. After that, we will see the performance measure for regression. This confusion matrix is not used for regression, and why, that also I have explained. After that, we will see where the machine learning model fails, that is overfitting case and underfitting case. So watch the entire video. Machine learning. Machine learning is a branch of artificial intelligence that enables computers to learn from data, make predictions or decisions without being explicitly programmed. Means machine learning is a branch of artificial intelligence that allow computers to learn from data and make predictions or decisions without explicitly programmed. Means computers now can predict or make decisions from data. They don't require hard coding. ML learns from data, not from code, in short. So what is need of machine learning? Machine learning is used to handle large data sets, to automate decision makings, to improve accuracy over time, used in fraud detection, recommendation systems, image recognitions. We will see now what are types of machine learning. Majorly, there are three types, that are supervised learning, unsupervised learning, and reinforcement learning. But there is one more that we are going to study, that is semi-supervised learning, which is combination of both supervised and unsupervised learning. So we will start with supervised learning. In supervised learning, the model is trained using label data. Label data means input plus output plus correct output is given in training dataset. The key idea is model runs from known answers and predict output for new data. The types of supervised machine learning are classification and regression. Classification uses best fit line, and regression is used when the dataset is continuous. Examples for supervised learning are fraud detection, spam filtering, and house price prediction. Next, we will see unsupervised learning. In unsupervised learning, the model is trained using unlabeled data. Unlabeled data means only input is given, no correct output. So, the model finds hidden patterns or groups in the data. The types of unsupervised learning are clustering and association. Examples of unsupervised learning: customer segmentation and market basket analysis. So the next type is semi-supervised learning, which is combination of both labeled and unlabeled data. Labeled data means we use labeled data in supervised learning and unlabeled data in unsupervised learning. So the small amount of labeled data is plus large amount of unlabeled data is combined for improving the accuracy. So the examples of semi-supervised learning is image recognition with few label data and speech recognition system. This type is used because unsupervised learning in unlabeled data takes too much time to train the model, and in supervised learning, to label the data is costlier. So to improve the accuracy of unlabeled data, we add some label data into it. So it saves our cost and improves the accuracy too. So the next is reinforcement learning. Reinforcement learning is based on reward and punishment. The key idea is agent learns by interacting with environment and receives reward for correct actions. The components of the reinforcement learning are agents, environment, and reward. Example: game playing, chess, ludo, self-driving cars, robotics. Means suppose we are teaching robot to walk. If he walks properly, we will give plus one mark, means that is reward, and if it fails, we will give it punishment, that is -1 mark. So from this he will learn and improve its accuracy. So this is a reinforcement learning. We will see the difference between two major types of machine learning, that is supervised learning and unsupervised learning, in 10 bullet points. So the first point is it uses labeled data, it uses unlabeled data. Labeled data means it has input and output, it has only input. Works under guidance of teacher, no guidance of teacher, cause it has output too, but it doesn't have. Good goal is to predict the output, and the goal of unsupervised learning is to predict the hidden patterns, find the hidden patterns. Output is known during training, output is unknown during training. Used for classification and regression, used for clustering and association. Example, spam detection. An example of unsupervised learning, customer segmentation. The supervised learning is more accurate because answers are known, and this is less accurate because it depends on pattern discovery. How our model learns from patterns. Learning requires more label data. Preparation. No need of labeling. This saves time. Evaluation is easy. We use accuracy, precision, recall. Evaluation is difficult because there are no true labels. So for this we use different labels like mean, square error, etc. So the key difference was supervised machine learning predicts output using labeled data, whereas unsupervised learning finds hidden patterns from unlabeled data. We will see the steps to build a machine learning model. There are 7 steps. The first is gathering data, in which we identify the problem and collect relevant data according to that problem. The data can be collected from files, databases, internet, sensors, or mobile devices. The more quality data, more accurate predictions. Next one is data preparation. In this, the data can have missing values, wrong ages, etc. So we remove duplicate data, fix those missing values, convert data into proper format, and structure the data set. Prepared data is easier to process. The next step is data wrangling. This step is also called data cleaning or data transformation. Here we handle outliers, normalize or scale data, encode categorical variables, convert data into usable form. So the outliers means, suppose we have data set like 10, 20, 30, 40, 50, range from 10 to 30, and there is some data like 100. So this becomes the outlier for our this data set. It will affect the mean value, etc. It will affect accuracy too. So we remove these types of outliers. Normalize or scale data. Suppose we have 3 to 4 columns and which they have data like 200, 400, 500 in one column. In another column there is 1, 2, 3. In third column the data ranges from 8, 9, 10. Suppose this example. So the model will think that these big numbers are important and these small numbers are not. So that's why we normalize our complete data set. Or scale is, if small values we will scale them, and we will normalize the larger value to smaller. Make them in proper format. Encode categorical variables. Categorical variables means there is textual data like strings, etc. So to train the model we have to convert them into numerical data, that is encoding. The next step is analyze data. Here we find the patterns and trends, understand relationships, use graphs and statistics, identify important feature. From this we get our important feature and which feature we have to remove, find the relationships between the columns. In short, we analyze complete data set. The next step is to train the model. Here we select a suitable algorithm according to our problem like regression, decision tree, etc. And we train model using training dataset. The model learns patterns from data. Test the model. We split our complete data into training and testing. From training dataset, we train model and we keep small part of that data for testing, and we use that data for testing purpose and evaluate the performance using accuracy, precision, recall, F1 score. Means how good our model is. We evaluate that using these terminologies. And the last step is deployment, where we deploy our model into real systems, integrate it with a website, app, or APIs, monitor performance continuously, and update model whenever needed. So these were the steps for building the machine learning model. Now we will see the measures on which we decide that our model performing well or not. We evaluate our model. So for this, first let suppose one example dataset, that is marks and results. So this marks column is our input feature and the result column is our output feature. We pass this marks and it predicted this result, that is fail or pass. So we have this complete dataset in which we divide it into two parts, that is testing part and training part. So for both values we have our actual value and the model that predicts false. Like we have actual value for 60, that is pass, and the predicted value by model, that is pass or fail, any value that should be. So we will first see what is confusion matrix. We will write here actual values and here predicted values predicted by model. Suppose the actual value of 60 is pass, so the actual value of 60 is pass, and we pass the model the same value and it predicted it pass too, so this becomes true positive. Means it predicted it positive like pass, and the actual value was also positive, so it becomes true, so true positive. And suppose we the actual value for 60, the actual output was pass, but the model predicted it fail, so it predicted wrongly, so we write here negative. And it predicted false, for false, that was negative, so we write here negative, and the prediction was wrong, so here we write false. Similarly, the actual value, suppose the actual value of 31 is fail, but the model predicted it pass, so the model predicted positive value, that is pass, so we write here positive, and the prediction was wrong, for that we write here false. Same for negative, that the predicted value was negative, means fail, so we write here fail, but actual value was also fail, so the prediction was right, for that we write here true. Now we will see those measures on behalf of that we define our model is good or not. We evaluate our model. So the first measure is accuracy. Accuracy measures overall correctness of the model. Means out of total predictions, how many it predicted correctly. So the true positive, true negative divided by total. Out of total, how many it predicted correctly. The next one is precision. Precision measures how many predicted positives are actually positive. Means the total predicted positive cases from which how many were actually positive. So that is true positive divided by true positive plus false positive. This was wrongly predicted correctly. Means wrongly corrected, that's positive, but that was actually negative. So out of total predicted positive, how many were actually correct. The next one is recall or sensitivity. Recall measures how many actual positive are correctly detected. Means how many were actually positive, and it detects those actual positives. So that is recall. Out of actual positive cases, how many are detected, and this recall is important in fraud detection and medical diagnosis. Next one is specificity. Specificity measures how many actual negatives are correctly identified. Means how many actual negative values were there, and it how much of that it predicted correctly. So the formula is true negative divided by true negative plus false negative. How much was actual negative, and from that how many it predicted correctly. The next one is f1 square. F1 square is harmonic mean of precision and recall. So f1 square is mean of this precision and recall. So the this f1 score is used when both false positive and false negative matters. So the formula for this is 2 into precision into recall divided by precision plus recall. There are two conditions where machine learning model makes wrong predictions. So we will see what are they. The first one is overfitting and second one is underfitting. In overfitting, it has high variance problem, and in underfitting, it has high bias problem. So we will see what is variance and bias. So in overfitting, it has high variance, and the variance is error caused due to too many features for training. Means the error caused by giving too many features for training to the model. And underfitting has bias problem, means the error caused due to less features for training. Means while training we provide two less features. So we will see first difference between and then understand using this diagram. So in overfitting, the model learns too much details from training data, and in underfitting, model learns too little from the training data. It performs well on training data. It performs poorly on training data. So caused by due to too many features, and this caused due to too few features. It performs poorly on testing data. It also performs poorly on testing data. As we see, this has high variance problem and low bias, and this has high bias and low variance. So the training accuracy is high and testing accuracy is low in overfitting, while in underfitting the training accuracy is low and testing accuracy is also low. So this is underfitting, where it learns too few features and it learns too many features. So the overfitting is oversmart, where he memorized the data and the curves fit every point, while the underfitting undersmart means doesn't understand the data. So in optimal case, the best fit line is drawn, and based on this the predictions are done. But in overfitting, what happens? The these lines, the these lines, these curves fit every point. So it makes the wrong decision because it learns too much from the training data. Whereas in underfitting, in complex patterns, it makes just a simple line. So this also causes the problem. So this was the cases where the model predicts wrong outputs, wrong predictions.